I wanted to take a few minutes and put together a video about the chemistry in your life assignment. I've had a few questions come in during lecture that we've talked about briefly, but I just wanted to put it all together. So this assignment is due at the end of the summer session, so it's due June 25th. It represents 10% of your course grade. It's 50 points total. So this assignment kind of came out of the fact that I know not everyone in this classroom is a chemistry major, but whether you want to acknowledge it or not, right, chemistry is all around us. Chemistry plays a huge role in, for example, the food we eat. So if you enjoy cooking or baking, that is chemistry. Chemistry is also playing a big role in the materials we work with on an everyday basis. So the lithium in your lithium-ion battery, or the material that's used in the touchscreen of your cell phone. So whether you know it or not, right, chemistry surrounds us. Chemistry plays an important role in the quality of the air we breathe, the water we drink, right? The chemistry of that material is highly regulated. We want to be drinking clean water. We want to be breathing clean air. So I would like you to find something about chemistry that interests you, some topic that interests you. And it could relate to your major, it could relate to a hobby, a sport, or something like baking. Maybe you're really interested about what is exactly taking place when I'm baking a batch of muffins, or if I'm baking bread. What is the reaction taking place there? Or if there's a special food, if you really like pickled food, right? What's the chemistry that's taking place there? So I want you to find something that relates to you, that you find interesting, and really dive into the chemistry of that. What is the chemistry behind that process or that event? And just as an example, I've had students do presentations on the chemistry of nail polish, the chemistry of different types of makeup, the chemistry of cleaning agents, the chemistry of cooking, the chemistry of fermentation, like kombucha, for example, the chemistry of nutrition supplements. I've had a couple athletes who've talked about the different supplements that they take and how they work. So I'm looking for a one-page PowerPoint slide graphic on that topic, right? I want an infographic. I want it to be something that catches your eye and is also interesting and engaging at the same time. I want to learn something from this, but also when I see this, right, I want to say, yeah, I want to read more. I want to find out more about this topic. I also am going to direct you to this Compound Chem website where there's a guy who does several of these. He usually does one in a week, just to give you an idea of what has been done. I don't want you to use one of these. You can just go there to kind of take a look at what has been done for these graphics. So here's the grading rubric. This is also available under the assignment in Blackboard. Basically, the information, it's clear. You make a clear connection with that information, the information that we're talking about. I also want you to go a little bit beyond the common knowledge, right? Like I said, I would like to learn something by looking at this infographic and reading the information that it contains. You also need to represent the chemical information accurately, right? This is a chemistry class, so I want you to represent the chemistry you're talking about in an accurate way. And you also should understand this material a little bit, right? We can't just copy and paste something that you found and just stick it into a PowerPoint slide and say, there, I'm done, right? You need to understand that material and interpret that material. It also should be clearly organized, easy to follow, right? I want a good mixture of text and figures. I don't want just a full PowerPoint slide of text that I have to read through. So, the figures, they need to be accurately representing the material and a decent amount of this PowerPoint slide, right? The figures, they should be good figures, so take some time to make the figures and choose the figures you want to incorporate in this PowerPoint slide. And they should be appropriate for what we're trying to represent, what you're trying to represent and convey to the reader. And the text that you include, right, try to make it easy to read. Don't use a tiny font. Don't use an obscure font that's really hard to read. So the color, the size, right, should be pretty easy to read for your average person, free from grammatical and spelling errors. And most importantly, the last aspect here, you need to reference where you get this content from, right? If you are taking anything that is not your own creation, you need to let me know where that information came from. So that's the grading rubric I'll be using for this assignment. As you can see, there are 10 different grading criteria. This assignment is worth 50 points. So each of those criteria are 5 points each. So to give you an example of what I'm talking about for an infographic, this is what I made for the assignment. I am an avid distance runner. I ran in high school, I ran collegiately, I ran after college, and I still run today. I still run maybe 60 to 70 miles a week every day. And so growing up, I idolized Lance Armstrong. I watched him win the Tour de France several times. And so a product of me being interested in distance running and really endurance events in general, I became aware of something known as EPO, or erythropoietin. And so what it is basically it's an amino acid sequence. It's 165 amino acids long, and it's naturally produced in your body. So you and I, we naturally have erythropoietin in our body, and it's usually produced in response to hypoxia. So basically you had an event where you had a decreased amount of oxygen. So maybe you were sprinting really vigorously, you were working out vigorously and became short of breath. Right, you're not able to carry enough oxygen to support the activity you were doing. That's a natural way to force your body to make more erythropoietin or more EPO, is by working out in an anaerobic fashion that starves your body of oxygen. Your body says, okay, I need to carry more oxygen. How can I do that? Well, I'm going to produce more EPO, and what EPO does is that it's a growth factor that stimulates your body to make more red blood cells. So you had this event, or you continue to have this event, where you're working out in a way that's starving your body of oxygen. Your body says, I'm going to fix this by making more red blood cells so I can carry more oxygen. So EPO is that growth factor that stimulates that process. And so what I found really interesting when I was researching and putting this together, right, from my chemistry background, I understand the chemistry, I don't know everything about biology, but what I found amazing was that your body, right, we use red blood cells to transport oxygen. Your body is making 200 billion red blood cells a day. An incredibly astronomical number to think about, 200 billion red blood cells a day. And this is also important as well, those red blood cells, they have a certain shelf life. They live for about 120 days. So, right, the red blood cells you have now are not the same ones that you're going to have 4 months from now, right? Your body's going to have new red blood cells that they've made. So this is all well and good. This is a natural process, right? Naturally, you work out, and this event occurs, and naturally your body's going to make more red blood cells. Well, what if I could separate, right, all of that work from the production and release of EPO? So in the early 1990s, out came recombinant DNA, which is basically a way of taking the genes that are used to produce EPO. Your body reads those genes out, and it says, okay, make this protein of this sequence. So we can also do that in the lab. I can take that sequence and I can insert it into a plasmid, and I can give that to a host cell and say, pump out this protein, and pump it out until I say stop. And so we can make this recombinant EPO, so non-natural EPO. And that's what was done. And this was done in a way to help people, because another people that suffer from anemia, right, low red blood cell counts, are people that are often going through chemotherapy treatment, because red blood cells, they're rapidly growing, right? Chemotherapy targets rapidly growing cells. So this recombinant EPO was a treatment for cancer patients that were anemic, that had low blood cell counts. Well, the endurance athletes also thought, hey, I can use this as well, because what do I need? What do I want? I want more red blood cells. So I can take EPO to help with that. And so it just radically and drastically changed the landscape of endurance athletes in the early to mid 90s, early 2000s. It really took off because EPO was out there, it was available, but we were not able to test for it for a long time. And so for the cancer patient who has low red blood cell counts, right, EPO is helpful. It helped them make more red blood cells. For the athlete, it was an unfair advantage because it forced their body to produce more red blood cells. If you have more red blood cells, you can carry more oxygen. That's incredibly important in an endurance event like the Tour de France that Lance Armstrong was participating in, or say marathon running or long distance running. So very early on in the early 90s, athletes started to use this and unfairly, right, stack the deck in their advantage. So early tests were developed around the 2000 Sydney Olympics, but they weren't the greatest test. And so the key to this test was when you naturally make EPO in your body glycosylates it, which basically is just a fancy way of saying that your body adds a few sugars onto that protein as your signature. Say, this is the EPO I made. Recombinant EPO does not have those sugars, right? So you may have an EPO protein in your body that has 5 or 6 sugars on it. If they're testing your blood and they find EPO with 0 sugars on it, if they find an EPO protein that does not match the EPO found in your body, right? If there's no glycosylation, if there's no sugar attached to that protein, it's a sign that you have recombinant EPO in your blood and you've been blood doping. It took a long time to get this test really developed, and so before that test came out, the other way of testing for was this person blood doping was using a hematocrit test, which is basically a measure of how many red blood cells do you have in your blood. And so through testing hundreds of thousands of people, the average levels for men are about 40% and 31% for women. And so they basically said an early level of you've been blood doping was, do you have greater than 52% of hematocrit? They kind of set that as the baseline for what you can have and cannot have. So 52% was our hematocrit level before we could test for recombinant EPO. And so many of us know this now because we've had large investigations into this, but Lance Armstrong was ultimately found to have been using EPO during his build-up and his winning the Tour de France. Others that were also found to blood dope were his competitors at the same time. So Marco Pantani, he never tested positive for EPO, but he was measured to have a hematocrit level of 60%, right? A huge number, much higher than your average person. Jan Ullrich, who finished second to Lance Armstrong a few times, all of his results after 2005 were also erased for positive tests. Floyd Landis served a 2-year ban, and he lost his 2006 victory for the Tour de France. So at this time, Greg LeMond is currently the only American to ever have won the Tour de France because Lance Armstrong and Floyd Landis both lost their victories. Tyler Hamilton was also included in that, and he also received a 2-year ban. And it's touch distance running as too. Many distance runners have tested positive for EPO. The most recent was Rita Jeptu, who also received a 2-year ban. And so what's kind of interesting is early on, like I said, they did not have a way to test this. Once they developed the test, they went back to test all the samples from the 1998 Tour de France to see that 92% of riders tested positive for EPO. And it's amazing to kind of go through and read the history and read the stories of what was going on, because there were riders who one year they were the top. They were the top 5, top 10. The next year they said, I did even more training, was even better shape, and I just got dropped by everyone. I knew something was different. And that story of the clean riders, was shared many times of basically it didn't matter what they did. It just seemed like all those people out there were suddenly leagues better than they were in the previous year, and they couldn't quite explain why. Well, now we know why. It was because they were blood doping with something like EPO. They were unnaturally increasing their levels of red blood cells, which allowed them to carry more oxygen. And that's incredibly important in such long events, right? These long endurance events like the Tour de France or running a marathon, because the more oxygen you can carry, the more efficient your body's going to be, the less likely you are to build up fatigue after day of riding over 100 miles. So just kind of something that I was always interested about. I never really knew the whole process of EPO. I knew it made more red blood cells, but I didn't know everything about it. So this is kind of what I'm looking for your infographic, for your chemistry in your life. And me coming from a science background, right, I probably have more text in here than you should have, but this is just a general idea. I tried to include, everything that was relevant to kind of describing how EPO works, why people were using it and abusing it, and finally how we were able to test for it in this case. So hopefully that gives you a good idea of what I'm looking for this assignment.